Hello everyone, can you hear me? Hello.
Yes, yes,
Okay.
yes.
Okay, so we are just waiting 1 minute or 2 minutes, then we'll start. Just a minute. Okay, so in the meantime, I also give you an announcement about our upcoming online training program, which will be held on 12th January. So if you want to join this online training program, you can easily make the registration. This class will be start from the 12th January and admission lastly the 11th January. And basically, first 10 registered people will get the 50% discount on this online training program. And it's a total 7 days online training program. Class will be held mainly Friday and Saturday in a week. And each day you can take the total 3 hours live training program. And if you want to join this online training program, you can simply contact in this WhatsApp number, as well as you can also in the email about that. And basically, in this online training program, just focusing for the beginners who don't have any knowledge about the Google Earth Engine, who don't have any knowledge about the Python or JavaScript programming. So after completing this online training program, you are able to do any types of remote sensing analysis using Google Earth Engine platform very quickly and efficiently. Okay, so here are all of these things I already included in the video description. You can simply check it. Then if you want to join, simply contact in this WhatsApp number and also contact with this email. Thank you. Okay, so hope all of you hear me. So okay, so basically today is our fourth number of class. Okay, so before I start the class, first of all, anyone any problem regarding the previous class, you can tell me about that. We try to find out that problem solving first. Okay, so any problem for that, anyone or previous class?
Hello,
Yeah,
yes, I
please.
have a problem.
Yeah. So if it's also better
Uh,
if you can simply share your screen and then open your code. Okay, then I can easily show it and then find out the problem. What? Okay, so
okay.
okay,
Can you allow me to share my code?
yeah, yeah, you can also share, no problem. Or also you can
Okay.
share your code link. It also better. Or if possible, you can also share your screen. Then you also try to check the
Okay.
problem.
Okay, I can share over. Okay, sure. Okay, can you see my screen?
Yeah, coming. Okay.
Okay.
Yes.
So I'm trying to download some images of Sentinel and Landsat.
Yes.
I start with Sentinel first, but when I try to download my images, I get a problem
Okay.
in my Google Drive. I have this image like, let me show you this. Okay, this is the code. So I have
Okay. Okay. So
selected
is
the
it
Sentinel.
exported or not?
It's exported with too many images.
Okay.
I think it will come with one images.
Okay. So did you open this type of image in your ArcMap software or other GeoSpot software? What you get from here?
I'm not try it yet.
Okay. Okay. So I think it will just show provide you only for the one image, and under this image including all of those band. Okay. So,
Mm-hmm.
but in this time we can get a lot of images. So okay. So simply check your code. you try to add the B1, B2, B3, all of those band. But one problem is you can do in here. This problem is that, okay, so you can simply copy the image collection, Copernicus, S2SR, and Harmonize, open your dataset. Okay, just simply open your image collection dataset from the
This
Google Earth
one?
Engine data catalog.
Okay, okay.
Then you can easily find out what you
Nice.
wrong in here. So
There
Sentinel, open
is
the Sentinel,
Sentinel
multispectral,
and
Sentinel 2, yeah.
yes. And yes, I'll take it.
Okay, go to the bands.
Okay. Thanks. It's not that I choose. I choose this one. This. Because I want the image of 2015 and 2023. So I've choose this.
Okay, so in this time we also need to you can see the scale about that. You can see scale. Okay, so mainly when you can get this type of scale, not only for all data set, some data set you can get the scale such as Sentinel, also Landsat surface reflectance. So we can find out this type of scale. So mainly when you want to put this the scale value, then we can get the proper wavelength or proper pixel of the image. Okay, so
Okay.
now you can simply share your code. I set the scale and try to again. So click on the get link button and share this code with me. And before that, also share your region of interest. Okay. So for that, simply go to
Okay.
the asset tab and click on your boundary shape file, and then share it. Then send me the code link. Then it also better. Yeah. Click on here.
Okay, like
Click yes, and click to the share button. Then you can simply put anyone can read. Anyone can read. Just put the anyone can read. No problem. Yeah. Then done.
Okay.
Click to the done. Okay. So now click on the get link button.
Okay.
And then send me the link. Then I can easily access your code with your boundary and get the result.
Okay. So
Yeah, send here.
you want I send you on
Yeah, send the Google
class?
Meet, inbox. No problem.
Okay.
Add number tab. Okay, you can also put the classroom.
Right.
Yes. Okay.
I can put it in the comment.
Okay, no problem.
Right. Okay. Okay. So to solve this problem, I have to rescale the image at this resolution
Yes.
0.0001.
Yeah.
Is right?
Yes.
Okay. If I make a function to rescale the image, it can come in my Google Drive as a single image with all the band I've selected.
Yeah, so in this time, you can see all of those band is the same scale, 0.001. So in this time, you can simply multiply. After select all of those band, use here the multiply function and put this scale value. And then it will be okay.
Like,
and it also better use to, suppose first of all, you use the filter bounds, mainly where, then how, and then when. Okay, so it's serially where, how, and when. Where means filter date. After you put here the filter metadata and then put here the filter date, and then use here that select function. Okay, then it's better to use. So mainly filter bounds, filter metadata, and filter date. It's the sequentially one by one we write. After that, select our all of those band. Yes, use the select function. Dot select. Yeah.
yes.
Okay.
What if I create this a new variable and I multiply by the factor of rescale?
Yes.
It's better?
Yeah.
Okay. So scale. images is right, or EE number
So
when I want to
you can
multiply.
simply multiply with this value 0.001. Put the parenthesis and
Oh,
multiply 0.0.
okay, okay. So, so
And another thing is that mainly Sentinel is not all of those band the same resolution. Here you can see, you can put here the
mm-hmm,
scale only 10 meter. You can export image to drive. Export image to drive in this option, you can get the scale value. You can put here the scale value 10 meter. Okay, you can see 10 meter. But all of those scale is not same resolution. All of those band is not the same resolution. So we can check
mm-hmm,
about that. Suppose in this time you need only for the 10 meter bands. So you need only select the 10 meter band. Okay, in this you can say
mm-hmm.
B1 is the 60 meter, B2 is the 10
Okay,
meter, B3 is the 10 meter, B4
okay,
is the 10 meter, and B8 is the 10 meter. Okay, so you can simply
okay,
select this only
okay,
for the 10 meters band which is available. Okay,
okay.
then we can get easily from here. And when you need the 10 meter band, then you can simply put the 20 meter band. Simply put here the 20 meters band and also select all of those 20 meter band.
Okay.
Then we also get the
So
value.
like two, before.
Yeah. Mainly B2, B3, and B4 and B8 is the 10 meter.
Okay.
Is it run? Yeah.
Sentinel
Yeah.
element
Sentinel
progress.
2 to yeah, yeah. So now try to again whatever you check. Yeah.
Okay.
Okay, perfect. Okay, so in the meantime, anyone have any other problems?
Mm-hmm.
You can tell me about that. We try to discuss about that problem for previous class or okay. I think it need take some time to exporting.
Yes.
So I think first time it not executed because you select that all of this band, but you put here the same scale value. Okay. So now you put here the B2, B3, B4, and B8, which is the 10 meter resolution. So I hope
Mm-hmm.
there is no problem. It will be okay. 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 So you try and then
Okay.
face any problem again. Knock me. I will try to solve the problem. Okay.
Okay. Okay. Thank you. So I
So
can stop sharing,
yeah, now it's stop the
my
sharing.
screen.
Yeah, it's stop the sharing.
Okay.
Okay. So any problem? Okay. So if there is no problem, then I go to my share my screen and then. Okay. So basically today is our fourth number of class. So basically today we discuss about that how to remove cloud and haze from satellite imagery, mainly Landsat and
Okay.
Sentinel imagery. How we can easily remove the cloud and haze,
Okay.
as well as also try to discuss about the DEM data set, mainly how we can easily use the different types of DEM data, NASA SRTM data, and other STAR data. This type of data, how we can easily use, and then easily create the hillshade map, slope map, aspect map, Okay, this type of tab I can easily create, as well as you try to discuss about the land surface temperature monitoring using Landsat satellite imagery. Okay, more satellite imagery we already discussed. So today try to focus the Landsat satellite imagery and make the land surface temperature monitoring, as well as how to calculate the average maximum minimum pixel value, any kind of pixel value, as well as standard deviation, this type of statistical value, how we can easily calculate it for any specific indices. Okay, and how to make monthly evapotranspiration. Okay, so basically it's not only for the evapotranspiration, any kind of data set. Suppose you need the monthly value, January, February, March, April to December. So this type of monthly chart, how we can easily create. Okay, so it's very important for the different types of work, because we already discussed about the 8-day data set. Okay, suppose 8-day, 32-day, annual, this type of data set we can easily get different times. We can already make the chart. But sometimes we also need about the monthly chart. Suppose January, February, March, April, May, this type of monthly chart, how we can easily create. I provide the example using the evapotranspiration, but using the same approach, you can easily create for any monthly time series chart. It can be NDVI, NWI, or others. Okay. So, okay, so let's go one by we try to discuss about all of those things. So first of all, how to remove cloud from satellite imagery. So mainly Landsat and Sentinel. How can it remove the cloud? Yes, so this type of cloud pixel value. So here you can see it show about the different types of cloud pixel value. But when you want to use here the CF max algorithm, then easily remove all of those cloud and get the very clear satellite imagery. So basically, you can see the CF max algorithm. So here you can easily, I also send you the link about that. You can easily try to read the algorithm. Then you can easily get a lot of idea about the CF max, how it will be work. Okay. So let's go about that. So first of all, I will show you that for Sentinel-2 satellite imagery, how we can remove the cloud from the Sentinel-2 satellite imagery. So first of all, I simply import a Sentinel multispectral instrument image. So here you can see this is the Sentinel-2 multispectral instrument level 1C, this data set. Okay. So just I simply import this data set. And it's a default variable name image collection. I simply change it S2. As well as I also import my boundary. Suppose Dhaka City, I simply import. And give the variable name as a RY. So now this image collection I need to filter for my specific boundary. So for that same approach it I will apply for filtering. So take a variable, suppose image. So S2 mainly where I need the image. For that I use here the filter bounds function. In this time I mentioned about my area of interest RY, which stored the Dhaka city boundary. Suppose I put at the filter metadata. Mainly in this time, suppose I put at the name, operator, and value. Suppose I need this image less than 1% cloud pixel percentage. So image properties, simply copy the cloud pixel percentage. And paste here. And operator, I set the operator such as less than, suppose, 1. Suppose when I need this image, I simply put here the filter date function and put this image, suppose 2016, 1st January from 2016, December 31. Okay, so I filter my image collection. So now all of those images, you can see how many images I want to get from here. Here I can get total how many images. So use here the size function to calculate computing how many total. I can get total 20 images. Okay, so less than 1, I can get the 20 images. Okay? But when I put here the suppose less than 10, then this number is also increased 28. Suppose when I put here that less than 90, then it also more image we can get 60 images. Okay, so in this time, suppose I put here the less than 1%, so it indicating that I choose only for those images which image will be not more than 1% cloud cover. So this 20 images is the less than 1% cloud cover image I take. And then I just simply use here the median function because I create the median composite. And then clip with my boundary shape file, which is ROI. Wi-Fi connection is the disconnected. Okay, so now it's okay. Yeah. So now can you hear me? Okay. Is it okay? Okay. 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 So now I try to display these images. So just use here the map dot add layer and call this object image and paste. And also focus the center of this boundary shape file. Use here map dot center object. Object is that ROI 10 meter and click to the run. I put at the zoom level 10. So now we can get this type of images. So now I just simply click on here and set the visualization about that. Such as, suppose I put at the B4, B3, and B2 band. Also increase the stress 98% for better looking. And then apply. Yeah, apply. So now we can get this type of image, you can see. But this image is not much cloudy because I use here the less than 1%. Okay. But we can get some haze, look like that haze you can see this time. Also you can hear. Okay. So in this time, suppose I just put here the 90%, then you can see what happened. In this time, when I put here the 90%, then the image number is also increased, as well as some cloud pixel also add in my images. Because in this time I take the total 90%, less than 90% images. So now let's check again about that when I apply the 90%, then what happened? So just I simply set the visualization from here. Okay. So now I can see we can get type of image. In this time we can get this type of, you can see haze, as well as we can get this type of cloud. Okay. You can see I can get this type of cloud. It is a cloud pixel. So it's a cloudy image. Also, you can get some haze. Okay. And it's very important. 90 in this time, why I put here the 90%? Because sometime, suppose when you want to work with the river bank, when you want to work for the coastal area, then you cannot find out any image which is the less than 1% cloud cover. You cannot find. Okay. Then you have to increase the value. Okay. Suppose you increase the value 50%, then you can get the image. You increase the value 90%, then you can get the image. For the cloudy region, such as coastal area, also river bank, where we can all time evapotranspiration and also make the cloud formation. So that's why this type of region you find out, you did not find out easily. The less than 1% image is not available for this region. So for that, we have to increase the value. But when you increase the value, then you can get this type of cloud, white pixel value, also get this type of haze. So that's why in this time, we are applying the cloud max function, and then we can easily remove this type of cloud and get the very clear satellite images. Okay. So I simply import the visualization and then try to show you that how it will be work for the cloud max function. Okay, so in this time here you can see this is this image I used in here, and Lancet Sentinel both of image we can get a band, this band called the cloud marks band. Okay, so in this time here you can see this is the one kind of band, cloud marks. Okay, so basically this band is the name is the QS60. This is the cloud marks band, and QS60, this cloud marks band have a 3-bit, bit 0 to 9, it's totally unused, and bit 10, this bit 10 has a 2 signal, 0 and 1. So 0 means that no cloud, 1 means that cloud present. Also you can see that bit 11, it have also 2 signal, 0 and 1. 0 means that no cloud, no, and also 1 means that cloud present. So in this time, I just use this cloud marks band and then select the bit 10 and bit 11, as well as also select the bit 10 equal to signal 0 and also bit 11 equal to signal 0. It's indicating the clear condition. Okay, and mainly it will be work for that CF marks algorithm. Using this algorithm, it will be work. So in this time, we are not going to the algorithm, just we are try to write the code and then find out the result. So in this time, first of all, you need to select the band QA60. Okay, and then select the bit 10 and bit 11. And then simply select bit 10 equal to 0 and also bit 11 equal to 0. Then it will be done. Okay, so let's go. We write the code. So first of all, my band name is the QA60.
Sir,
Yeah, please. Yeah, yeah.
sir,
So
I didn't get it.
okay, I can explain. You can see. So in this time, we are removing the cloud. Okay, so for that, we need to use a function. We need to use a band. This band name is the QA60 band. Okay, or cloud marks band. Okay, cloud marks band has a 3-bit 0 to 9, also bit 10 and bit 11. So mainly bit 0 to 9 it unused. Okay, and bit 10 has a 2 signal, 0 and 1. 0 means that cloud, no cloud, and 1 means that cloud present. And also you can see bit 11, it also 2 signal. Okay, 0 means that no cirrus cloud and 1 means that cloud present. So now we are just selecting the QA60 band. From here we select the bit 10 and bit 11. Okay, and after that bit 10 equal to 0 and bit 11 equal to 0, which is indicating the clear condition. Mainly 0 show about the no apex clouds, also you can see no cirrus cloud. So in this time we are just selecting only for the 0 signal.
So when we use bits 0 to 9,
Bit 0 to 9 in this time it totally unused. There is the no signal. Suppose 0, 1, this type of signal is not present. Suppose I also show you another example from that data set. Suppose Landsat. Suppose just open the Landsat data set. Suppose Landsat. Suppose Landsat 8. Suppose surf data set. Open. So in this time, you can also get the one kind of band. This band name is that QA pixel. Okay. So here you can see this is the QA pixel. So mainly it's the pixel quality attribute generated from the CF marks algorithm. And this band has some bit. You can see this type of bit 0, 1, 2, 3. Also you can see there's a lot of bit about that. Okay, you can see, and you can see the bit, all of those bit, and also some signal about that 0, 1, 2, 3. Okay, you can see signal. So in this time, suppose you want to work for the bit cloud, mainly for my region there is the no sono, there is the no other types of unnecessary pixel value. So that's why suppose I only need to remove the cloud and cloud shadow. Okay, So that's why I need to use here the bit 3 and bit 4. Okay, so then it will be okay for me. Suppose some region has also some snow area. Okay, so then you are also using the bit 5 to remove the snow for getting the clear satellite images. So in this time, you can see the bit 3 is the cloud and bit 4 is the cloud shadow. So you can simply set the bit 3 and bit 4 and then set equal to 0. 0 mainly it show about that no cloud, no shadow, no cloud shadow. Okay, so in the same approach, we also try to apply in here. Also, you can see the cloud shadow confidence.
So
So
can't we use clear?
yes, please
So can't we use clear?
clear which number bit.
Bit 6.
Yeah, you can also use it, no problem. Okay. So mainly cloud bits are set. Okay, so you can also use clear about that. Okay, so basically which bit you want to need, you can simply select and then also select about their signal 0 or 1. Mainly 1 is present. You can see 1 is the low, medium. Also you can see 3 is the high. So because you need, suppose cloud confidence is the none, simply put here the 0 or 1. Then you can easily do. So now I will show you that how we can easily use this type of bit and this type of single, and then we can easily remove the cloud. Okay, and basically it worked for that. Mainly the algorithm is the CF max algorithm. So in this time, suppose for the sentinel, then we are also talking about the Lancet. Okay, suppose, okay, so this type of cloud I want to remove from here. So for that, first of all, I need to the band about that sentinel. So just I simply open the sentinel2 image data set from here. Suppose sentinel2. So in this time, we are just simply copy the band name and then select the bit number and also select the single number 0 and 1. Okay, mainly we need to select the 0, which is indicating the clear condition for this. So bands QS60 band. Okay, simply copy the band name. Okay, so in this time, we are just make a function. Okay, using this function, we fill up all of those argument one by one. So just take a variable. Suppose I put the variable name is that cloud max. You can put any variable name, no problem. And now just use at the function keyword and put the element name, suppose img, and then put your argument in this curly bracket where just put our argument. So first of all, we need to select the band QA60. So just take a variable, suppose QA, and call your element name img and put at the select and paste that band name QA60. Okay, so in this time, this is the element name. Basically, in this curly bracket, we are do all of those things only for this element. Okay, which variable you can put here as the element name, you have to use the same variable also in here. Okay, because in this curly bracket, all of those things we do only for this element all time, not only for this function, any function. So now I just simply select the QA60 band. Okay, and then we need to select the bit number. Okay, so in this time we are get the 2 bit 10 and bit 11. So just take a variable. Suppose I put the variable name is that cloud bit max, and for the selecting the bit number we have to use this symbol 1 less than then put here the bit number. Okay, suppose all time, suppose you can put here the 1, then put here the less than then put here the bit number. Suppose I need to select the another bit number, suppose 11 bit number. Take the variable and put here the cirrus bit max, same 1 less than bit number, all time 1 less than bit number. Okay, so in this time 10 and 11 I select. Suppose I have the more band also bit. So the same process, simply take a variable and then put here the equal sign and then 1 less than put the bit number. Okay, so now just take a variable, other variable. Suppose I put the variable is the max. Now I have to set bit 10 equal to 0 signal and bit 11 equal to 0 signal. Okay, so for that I just simply call the QA Basically, QA60, this band is stored in this variable QA. And now I want to connecting this bit number. Okay, so for that, use a function bit wise and call the bit number 10, which is stored in here. Simply copy and paste, and then set equal to 0 signal. Okay? And do for the same things for the bit 11. So for that, simply call this band, copy and paste here, and now connecting the bit. So use at the bitwise AND function and call this variable slash bitmax. Simply copy and paste here and set equal to 0. Okay, so now it's indicating the clear condition. So in this time, this is my function. Okay, for removing the cloud from here, and all function what I return from here. So in this function, what I return. So in this time, I need to mark update. I need to update this image using this condition. So for that, I just simply use a function, return function, return this image, use here the update marks. And what is the condition? My condition is that this is my condition, okay, which is stored in this variable in here, marks. Simply copy and paste. Okay. So now we can, this is the function. This function we are just need to add with our image collection. Then we can easily remove this type of cloud will be removed from here. So I again explain. So first of all, you just simply take a function variable name, then function keyword, put the element name, then using the curly bracket, we have just put our argument. So in this time, my first argument is that I need to select the cloud marks band. Okay. After that, need to select the bit number. Okay. Then connecting the bit number with my band. Because basically this bit number come from this type of band. QA60 have a 2-bit. So that's why it already stored the QA function, QA variable. So use the QA bitwise and then call this variable name set equal to 0. And also same do for the equal to 0. Is indicating the clear condition. After that, we need to update using this update marks function and simply copy the variable name and paste here. So now this is the function. Okay. So now this function I need to add in my image collection. Then it will be easily remove this type of cloud. Yeah, please.
I just missed the last that you told that what does you use one less than 10.
Okay, so it is a sample about that. So all time, suppose when you want to work for that land set also, first of all, one less than put the bit number. Okay, so all time it is a sample about that. Selecting and mainly the storage the bit number. Suppose one less than bit number. Also you can see about that. Suppose when you want to work for the land set, suppose you can see the land set for the different types of bits. Suppose bit 3 on 4, we same. So just we put at the one less than 3 or one less than 4 for selecting the bit number.
Then where we use the 0 and 1 that you told that 0 indicate the no cloud and 1 indicate the cloud.
Yes, yes. Because in this time here you can see it show about that a band to signal 0 and 1. 0 is means about that there is the no cloud, and 1 is represent about that cloud present. 0 no cloud, 1 present, cloud present. Okay, so that's why in this time we are just set equal to 0.
Oh, that
and find
EQ means equal.
Yes.
Okay.
So now this is the function. This function you can simply set with our image collection. So for that I just try to show you the 2 images. So just I simply copy the same from here and add this function. Basically this is the function. In this function I need to add. So just I simply paste. And now how I can add? Simply use a function. This function called that map function. And then simply copy the variable name, function variable name, and paste here. Okay. So now this function is set with my image, and we can get the clear condition of the satellite image. So just I simply take the another suppose image cloud free. I change the variable name. So now I display this result. So for that, just use here map dot add layer, and then simply copy and paste and click the run. Okay, we'll also set the visualization for this second layer. Also import that. So simply copy. I put the layer name, suppose it's the cloudy. And paste here this visualization variable, and then put this cloud field. Now click to the run. So now this type of cloud will be removed from here, and we can get this better image. Okay, so now here you can see this type of cloud will be removed, and we can get the, okay, I'll zoom, then it will be better. You can see this type of cloud, and also haze, okay, for this cloudy image. But when I use here the CF max function, the cloud max function, then this type of haze also remove, and also remove this type of white pixel value, and we can get the very clear condition of this. You can see this type of cloud will be removed. Okay? So now we can easily identify where is it. Okay. Otherwise, when you want to make the land use land cover classification map using this cloudy image, then we did not get the better result. This type of pixel, cloudy pixel, and also haze pixel mix with the build up or barren land, and we did not get the better result. So here you can see this is the cloudy image, and this is the cloud free image after applying the function of the cloud marks band function. Okay, and it's very neat when you want to work for that coastal area or river bank, which is not available for the less than 1% image, is not available. Okay, then we are just applying this technique, and you can either remove all of those cloud and get the very clear satellite images. Okay, so now we can easily use it for the different types of remote sensing work. Okay, so anyone any question for removing this cloud? And this same approach we also apply for the Landsat also. Yeah, please.
So for Lancet, for some types of bit, we didn't get any 0 1 that signal.
Yeah. Okay. So for that we are considered the 0. Suppose cloud there is the no bit number, so that's why then we select the equal to 0. Okay. Suppose cloud shadow there is no signal, so we set equal to 0. So 0 indicating
same
the,
as Sentinel.
yes. Okay. So I also show you about the Landsat also. Okay. So then it will be better. Okay. So let's go. Okay, so for that I show you that process for the, suppose LST monitoring. So basically I want to make a land surface temperature map using the removing the cloud and using this image for mapping the Landsat LST map. Okay, then also better. So okay, so just I simply open a new code editor. Okay, so in this time I just use here the make the LST map. and also show you that how we can remove the cloud from the landscape. Okay, so mainly LST map we are using at the surface reflectance image. Okay, because surface reflectance image we can easily get the thermal band or brightness temperature band. So that's why for the LST mapping or land surface temperature mapping we are using at that surface reflectance this image. Okay. So just like simply open the surface reflectance, here we can get all of those things. Okay, you can see all of those band, and mainly this band is very important. So it's the STB10. This time its name is the STB10, and this band called the surface temperature. It also called the brightness temperature. So in this time, I need to use this band to make the LST map, and this unit is that Kelvin, but we can easily remove, we can easily convert in degree Celsius. For doing that, no problem. So this band we also need about that when you want to make the LST, as well as also you can see about that for the cloud we can get this type of QA pixel. This band name is the QA pixel for removing the cloud. And mainly from here we are just using the suppose cloud and cloud shadow. So removing this type of cloud, we are just using the 2 bit, bit 3 and bit 4. Okay. So for that, first of all, I need to import the image collection. So first simply copy this and then filtering the image collection. So first of all, I just simply import the image collection and then give a variable name. Suppose I put the variable name is that suppose collection COL. I put the variable collection. And now, first of all, I need to filter for my, suppose I need to make the map for the LST map for the Dhaka city. Just I simply import the Dhaka city boundary shape file. Suppose this boundary simply import and give a variable name. Suppose put the variable name is that RY and just normal filtering. We already a lot of time we filter the image. So just use at the filter bounds function intersecting with our study area RY, and then suppose I need the make the LST map for suppose filter date, suppose year of 2023 from 1st January to what is the present time 2023 December 30. Just put here. Okay. So now in this time, suppose I check how many images I need to get from here. Print and use the size function. In this time, one function I did not use. I did not use the filter metadata function because in this time I use all of those images. Suppose all of those percentage images, all of those cloudy images I also consider in this time. I did not filter in types of images because I use the cloud max function. So that's why when I use the cloud max function, automatically remove all of those cloud and also cloud shadow. So that's why if you want, you can also ignore. Suppose simply you, in this time I did not put the filter metadata. Okay, I did not use this function because I use at the cloud max function or cloud max band to remove all of this cloud. In this image, I show you that you can see this image is very cloudy. We can get, suppose I take the median composite from all of those 35 images and then click with my study area, which is RY. So now what happened? We can get the very cloudy image because in this time I don't filter any cloud. So just add the suppose map dot add layer and use add the COL and click to the run. And also focus the center of this boundary shape file. Map dot center object is that RY. Click to the run. So now we can get the lot of cloud because I did not filter any types of cloud. So now show the visualization first. Suppose red band, green band, and blue band. First 98% stress and apply. Okay, so in this time you can get this type of images, not much cloudy, because in this time we can use the median composite, and it's not the coastal area or river bank, so that's why it's not much cloud. But in this time